This is the review for the multiple choice and short answer portion of the periodic trends test. Elements in the same blank have the same number of valence electrons. Well, if you look at the periodic table, the groups, which are the columns, all have similar numbers of valence electrons, so up and down in each group. If you go across the rows, those are the ones that have the same number of energy levels, or the same number of electron shells, would be the other way of saying that. Which of the following elements has 5 electrons in its valence shell? Again, if you look at the periodic table, you can tell for the representative elements, those are in S and P block, the left-hand and right-hand side of the periodic table, you can tell the number of valence electrons by the groups that they're in. So groups 1 and 2, and then 13 to 18. You look at group 1 has 1, group 2 has 2, 13 through 18, you look at the second digit. So since we're looking for 5 up here, we're looking for an element from group 15, and the element here that's from group 15 would be nitrogen. Who created the modern periodic table? Well, out of these choices, the only one who was at all involved in creating the periodic table is Dmitri Mendeleev. Other people who were involved in the process were Antoine Lavoisier, John Newlands, and Henry Moseley. Which term is the energy required to remove an electron? So removing an electron is turning the atom into an ion. So the energy required to remove that electron is called the ionization energy. Electronegativity is how strongly an atom pulls on other atoms' electrons. And then, of course, atomic and ionic radius are references to the relative size of the atoms. Atoms in row 3 are blank than atoms in row 2 because you have to know what the rows mean. Each row of the periodic table going across means as you go down, you're adding new electron shells or new energy levels, which means the ones that as you go down from row 2 to row 3, you're going to get bigger because you're adding a new electron shell. And oxygen is smaller than nitrogen because, so now we're talking about going across and comparing nitrogen, which is here, to oxygen, which is here. You have to know the trend in radius as you go from left to right. And as you go from left to right, atoms tend to get smaller, and they get smaller because as you add protons to the nucleus becomes more attractive. That doesn't mean the nucleus is better looking. It means that it has more protons to pull on the electrons, so the atoms get smaller. Which of these is the largest of the ions listed? Looking at the periodic table in terms of comparing ions, as you go down, so this is lithium, sodium, and potassium are all in group 1 in that order, going down. And remember, each time you move down a row, you're adding a new level or a new energy shell, which means that the one farthest down is going to be the biggest, whether it's an ion or a regular atom. This holds true for both. So the farthest one down here would be potassium, which makes that the biggest of those ions. Now, if you were asked to compare, for example, potassium to a potassium ion, the bigger one in that case is going to be the neutral atom. Neutral atoms are always bigger than positive ions, and neutral atoms are always smaller than negative ions. Which of these is an alkaline earth metal? Going again, these periodic tables. Group 1 is called the alkali metals. Group 2 are the alkaline earth metals. And then over here, group 17 is the halogens. Group 18 are the noble gases. So in this case, we're looking for an alkaline earth metal, so that'd be an element here in group 2. The one of these that's from group 2 is magnesium. Which of these atoms would attract more strongly and why? So the next few questions are all kind of related to the same thing. So if you're looking at these two atoms, what we're talking about, attracting electrons, in order to attract electrons, you're really looking at the center, the nucleus of the atom. And the nucleus is what's attracting the electrons. So this atom, atom A, the electrons can't get very close to the center because it's so big. whereas this atom is really small, which means outer electrons, or electrons coming in from the outside, can get much closer to the nucleus, which makes the smaller atom more attractive because the electrons can get closer to the nucleus. And so again, same, different question, but the reason for the answer is the same. So sodium, looking at the periodic table, sodium is over here and oxygen is over here. And remember that atoms get smaller as you go from left to right, so oxygen is much smaller than sodium. And since oxygen is smaller, that means that its electrons are being held closer to the nucleus. So oxygen would be able to attract electrons more strongly, which would give it a higher ionization energy. It also means that if you're trying, which would give it a higher electronegativity, and it also means that if you're talking about how hard it is to get an electron away, it is much easier to get an electron away from sodium because the sodium electrons are much farther from the nucleus than an oxygen, where it takes a lot more energy to get the electron away because they're being held more tightly. So smaller atoms have higher ionization energy. Which is more reactive? Again, similar basis for this question. So sodium has 2 electron shells. Potassium has 3 electron shells. And each of them has 1 electron in that outer shell. That 1 electron is the one that might be attracted to another atom. And because this one in potassium is so much farther from the nucleus than the one in sodium, that means this electron for sodium is going to be much more easily reacted with another atom. So the answer here is potassium, because its valence electrons are farther from the nucleus. And which is more reactive, fluorine or carbon? So again, fluorine, they both have 2 electron shells, but carbon's electron shells are held more tightly, fluorines are held more tightly to the nucleus, which means if you're talking about reacting with other elements, then these are closer, which means the nucleus in here, the nucleus is able to attract outside electrons more strongly than carbon, because carbon's nucleus is farther away, so it's not going to pull as strongly. So the answer here is that fluorine is more reactive because its nucleus is able to get closer to the electrons of other atoms because it's smaller. Okay, represent the increasing trends. Okay, so the direction in which these things increase. Electronegativity increases from left to right and increases from bottom to top. Okay, so the overall trend is like this, up and to the right. Atomic radius has the exact opposite trend. It gets smaller, so if you want to show where it's getting bigger, it gets bigger from right to left, and it gets bigger from top to bottom, so the trend is this way. So electronegativity and atomic radius have the exact opposite trends. Okay, so when metals gain or lose, well, all metals tend to lose electrons. Once you lose an electron, you formed a positive ion. And positive ions are smaller than their neutral atom because they have lost their outer shell. So again, to use sodium as an example, sodium has the 1, 2 electron shells. It's got 1 outer electron. Well, when that electron goes away, what happens is this outer shell goes away. So what's left is this inner shell, which is much smaller than what was there before. So positive ions are always smaller than neutral atoms. And this is kind of the answer we just gave in the last one, because they're losing an electron shell when they give away an ion, and so for what remains is the inner shell, which is smaller, pulled much more tightly to the nucleus in the center. So metals become smaller when they lose ions because they are losing an outer electron shell, and all the remaining electrons are able to be pulled more tightly to the nucleus. The trend in the energy required to remove an electron, which is called the ionization energy. Ionization energy has the same trend energy that electronegativity had in the slide that we looked at before. So ionization energy increases from left to right and increases from bottom to top. So the overall trend is up and to the right is the increase. Okay? So increases as you go up and increases as you go to the right. Two elements that would form +2 ions. So we're looking for elements that form +2 ions come from group 2, which is the alkaline earth metals, and that would include calcium, magnesium, and beryllium, strontium, barium, and radium. So you could pick any of those two. Any elements from group 2 would be in this category. Two elements that don't form bonds. Well, elements that don't form bonds are the noble gases. So helium, neon, argon, krypton, xenon, and radon. Okay, those are all the noble gases. Any two of those would work for this question. Two elements that form -1, that's going to be group 17, which are called the halogens. And the halogens are fluorine, chlorine, bromine, iodine, and astatine. Any two of those. Three properties of nonmetals. Nonmetals tend to be gases. At room temperature, they tend to be poor conductors of heat and electricity. And you could say poor conductors of heat and poor conductors of electricity. That would be two traits. And their solid forms are brittle, which means they crumble or break easily, unlike metals, which are more flexible and bendy. Two halogens. All right, we just did the halogens a couple minutes ago, group 17. So fluorine, chlorine, bromine, iodine, and astatine. Astatine would be the halogens. Pick any two of those. Two transition metals. Transition metals are any of the elements from the middle part of the periodic table or down in the bottom two rows. So you could pick from a large number of elements here, but let's say iron, copper, gold, silver, uranium, could be any of these, chromium. Pick any two elements from the middle chunk of the periodic table or the bottom two rows. Those are called transition metals. Two metalloids. Okay, the metalloids are kind of a tricky group. Right? They are the ones that follow this zigzag staircase over to the right-hand side. The most well-known sort of common metalloid is silicon, but other ones would include germanium and antimony. Antimony is SB. I was looking at arsenic, which is AS. Okay, those are all polonium, bismuth. Those are all metalloids. So you could pick any of those. Two elements that might have similar properties to copper. So if you're looking at the periodic table, copper is at the top of a group in the middle in the transition elements. So any other elements in that group should have similar properties. And the next two would be silver and gold. So those are two elements that should have similar properties. Which group do all the elements gain or lose electrons to become like? Well, all of the elements want to look like this group over here, group 18, which are called the noble gases. All of the elements are trying to get an electron configuration that looks just like the noble gases. If an element is shiny, malleable, and conducts electricity, it is likely to be a metal. Okay, those are the properties of the elements we call metals. They are shiny, tend to be shiny solids at room temperature. They are malleable, which means they're flexible, and they are good conductors of both heat and electricity. So those are all properties of what we call the metals. Okay, so that's it for the multiple choice and short answer section. The other video has the answers to the periodic table puzzle, and there will be questions just like these and a version of the periodic table puzzle on the actual test. The periodic table puzzle that's on the actual test will be a bit shorter than the one that is in the practice test, but the same basic principle. You'll need to use the clues to identify where those elements go on the periodic table. So there you go.